All right, good morning, guys. This is Wednesday or Thursday, February 24th for KAP. The warm-up is to evaluate these expressions. Evaluate is a fancy word for
Solve.
solve. So please substitute. Miss Lytle made these spicy, but these are spicy, so write them down first, substitute, and then solve on positive. All right, let's start with substituting, okay? Something to be careful about. I saw this a little bit yesterday. When A and B are next to each other, that means times, okay? Be very careful when you write, when you substitute in those numbers, you need to make sure you add that dot or whatever, because when you put two numbers together, that looks totally different. So tell me what you substituted. It would be 4 times
12.
quicker.
12 times 3 squared.
Okay, very good. So notice that Miss Lionel typed it in the parentheses like it said, and let's get solving. So order of operations tells me to do what first? Parentheses. You have to be very careful. We saw on other tickets, like some people like distributed the square. No. Okay. Do the grouping. That would give me 12 squared. Okay. Grouping is done. Next is exponent. 12 squared is
144.
Okay. Next would be
Multiplication,
which is
48.
plus 134.
192.
Very good. Okay. If you made a math error, if you made a math error, it's okay, but just make sure you understand order of operations doesn't take effect only when we're talking about order of operations. It's always there. Y'all good with that? Okay. Next one, tell me what to substitute.
4 to the power.
Minus 2 times 4 plus 6.
Yuchi, order of operations says parentheses 4 cubed minus 2 times
10.
order of operations says
Exponent.
exponents. We did this one yesterday. Hopefully you remember it. It's 64. Is it okay to work it out again? Okay, I'm saying we did that one yesterday. Minus 2 times 10. Next, multiply 64 minus
20
is
48.
44. Not fair. It's okay. It's okay. Any questions on that? Okay, you see how Miss Lila can make it spicy. You're welcome. Well, Miss Alice, yes, Miss Alice made it spicy. But we were in cohort. You're together. All right, y'all good with that? All right, homework. Here's the camera pause for the recording. Right. Okay, so today's activity, we're going to talk about how to simplify expressions. Sometimes the final is going to be cool, mean, and heartless and give you these really long expressions and to like simplify it. Okay? What simplifying means is taking out any fluff. Okay? I'm not actually finding the value of x. And what makes these equations versus what makes these expressions versus equations? These don't have the equal thing. Okay? I don't actually know the answers. I can just simplify. So again, with simplifying, I'm going to take out the fluff. We're going to see zero pairs a lot today, okay? What makes it a zero pair? A negative and a positive, those cancel out, make it zero pair, okay? What's different about today is we have different types of models. So on your desk, y'all have these at home. You can just sort of see mine. Whenever we have x's, do we know the value of x? No, okay? It could be 5, it could be 5,000. I don't know. But the green ones are positive, the reds on the flip side are negative. And then what we do know the value of, we can use these cute little yellow ones and stuff like that. Okay? So, looking at this first example that they've already done for me, I'm going to break it down. Okay? So they have negative 2x, so they did this shaded in rectangles. Are y'all good with that? This is negative 2x, positive 3x are these down here. Positive 5, again, I know that's actually 5, so they did 1, 2, 3, 4, 5. Minus 1 is the same thing as negative 1. Okay? Now, I noticed that they only did rectangles with rectangles and squares with squares. And that's because I can't combine rectangles with equal squares. I don't know if this rectangle represents negative 4 or positive 4 or what. But I do know that x and its opposite, x and its negative, would cancel each other out. Okay? So every time they circled it, it makes a what again? It makes a zero pair. And you have to say what is left. So talking about the rectangles, which are the x's, what am I left with? 1 a positive x, so 1 positive x. I'm just going to put x. Okay, you could put that 1. And then over here, I have 1 0 pair, and I'm left with 4. And it's going to be adding 4 since those are positive. Okay, so today we're going to take this big old jumble of mess, and we're going to turn it into this. Okay, I'm going to show you a couple other really cool things about this. Okay, when we plug in a value for x, we just say, hey, I want to say that x is equal to this. I never use 1 or 0 because those are the oddballs, but what do y'all want to use for x? 3, okay? I'm going to say that x is equal to 3, just for example. That means if I replace x with 3, if I say -2 times 3 plus 3 times 3 plus 5 minus 1. Let's solve that real quick. Let's multiply -2 times 3 is -6. 3 times 3 is 9 plus 5 minus 1. Left to right, -6 plus 9 is 15. -6 plus 9 is 3. 3 plus 5 minus 1. That's going to give me 3 plus 5. 3 plus 5 minus 1. 3 plus 5 is 8, fun fact. Minus 1 is 7. Do y'all agree with that statement? Yes. Okay? If Miss Lytle says x is equal to 3, do I get the same answer? Yes. Okay? That's how you know you did it right, is if you wanted to plug in verify. Okay? You don't need to do that, but if you wanted to check it, that's how you can. It is cool. Amazing. All right, so that's just how to check if you did it right, but of course we're still focusing on modeling. So try that next one. Ready, set, go. Draw out those models if you're at home. You can use the little algebra files that are at your desk if you really want to. Okay, pause and play. Okay, I'm going to draw. Are these rectangles or squares?
Rectangle.
Rectangles, and are they positive or negative?
Positive.
1, 2, 3, 4, 5, 6, 7. Oh my god, it's so hard to draw models. Plus 3x, are those positives or negatives?
Positive.
Do I have any 0 pairs?
No.
No, so in total I have 10x. That's it. Okay? Because it has x's next to it, we said that the x's were those long ones. I don't know what the value is, so it's a rectangle. Okay? All right. Moving right along. So, looking at this next one, again, I'm going to break it down. That 4x is what sign? Negative. That next x is going to be
Negative.
okay? When I think of subtraction, remember it's the same thing as adding the opposite. Okay, so it's the same thing, and it's okay, you're trying. You'll just start to discover, and it's really just going to be in your head. Anytime you see minus, that's the same thing as just a negative. Okay, so I'm going to have negative 4x, so let's start with that one. Okay, and then I'm going to take away another x or just put a negative x. So negative x, and then for the 2, we do squares or rectangles? Positive or negative? Positive. Okay, ask yourself, do I have any 0 pairs? No. Even though I have positives and negatives, they are not of the same shape, so I cannot cancel with anything else. So in total, I have, do y'all agree? Yes. Okay, try out the rest of the page, pause and play. All right, starting with one thing at a time. Negative 6x is going to be 6 of those negative rectangles. 2, 3, 4, 5, 6. Okay, then I'm going to put 5 positives or negatives. Positive. 1, 2, 3, 4, 5 positives. Okay, this one's going to be tight to fit. That 3, is it positive or negative?
Negative.
It's minus 3, so that's the same as putting 3 negatives. 1, 2, 3, and those are the squares, and then 2 positives. 1, 2. Now, do I have 0 pairs in this? Yes, I got a whole bunch. With my x's, how much is left over?
3.
I have 5 positives and 6 negatives, so there's going to be 1 negative x. Those are all going to cancel out. I'm left with negative x. And then over here, I'm going to be left with 1 negative. So that's the same thing as minus 1. Wow.
So easy.
Okay, that's why it's called simplifying, because it's taking out the extra plus. I'm not actually finding the value of x, but I'm simplifying. I'm taking out the extra unneeded things. Okay, for this last one, 3x, 1, 2, 3. Sorry, this is why I label, because they turn it mush. 1, 2, and then 7 negative x's. 1, 2, 3, 4, 5, 6, 7. Okay. 0 pairs. Am I going to have them? Yes. Left over with positives or negatives? 2 negatives. Okay. Those cancels out. I'm left with negative 2x. Y'all sort of kind of getting the feel for it?
Yeah.
Sort of, kind of. This one takes a little bit of time. Okay. Before we open up, I'm going to do one more technique, one more way to do this. And this is the way where I'm trying to get away from the model. Okay, so what I do is you sort of notice that the term, each of these terms takes on the sign that's in front of it. So this 2x took on that negative, that 3x took on the positive, okay, that 5 is positive, and then 1 is negative, okay? What I will do is, what I just did is I circled the term with the sign in front of it. Then I can only combine the ones that are similar to each other, so only x's with x's. Going back to those integer rules, do I have more positives or negatives?
Positive.
And how many more positives?
1.
Just 1, so it's just x. Okay, looking at these guys, those are called constants when they don't have a variable with them at all. Do I have more positives or negatives?
Positive.
How many more positives?
4.
Plus 4, a positive 4. And that's exactly what I did over here. Okay, I'll do it again. I'm going to skip a few because it's only on these really like funky ones that it really works. Okay, so again, breaking it down, each term with the sign in front. So the 6x is, I'm second on the bottom, that 6 is negative, that 5 is positive, the 3 is
Negative.
and the 2 is positive. Combine like with like. So the x's are like terms. Do I have 0 pairs? Yes, but what's left over? Negative 1, so a negative x. With the constants, do I have more positives or negatives? Negative 1. You'll see how I'm sort of doing that without the model? Yes. Gabby? A 0 pair is just like, it's opposites or 0 pairs. So if Miss Lyle had $4 in her bank account and then I added negative 4 in total, or I took away 4 in total, how much am I going to be left with? 0. Okay? So a 0 pair is just when you have positives and negatives like the same amount. Okay? You cancel out any 0 pairs because that's equal 0, and then whatever you're left with is what's left. So if I had like 6 plus negative 4, 4 of those negatives are going to cancel out with 4 of these positives, and I'm left with 2. Okay? All right. So let's go into the more formal notes. We did modeling. Let's get into the notes. We're just going to learn some vocab, but someone's already been using it. When addition or subtraction signs separate an algebraic expression, okay, so when you have an expression, anytime there's addition or subtraction signs, each of those things is called a term. Okay, so they've labeled one down here. I have an expression, it doesn't have an equal sign. Each one of those things is a term. The numerical factor of a term that contains a variable, so like this guy, when it's a number and a variable, they're getting multiplied. That number is called a coefficient. Have we said that word before? Yeah, we have. We talked about it with constant proportionality, the multiplier. That's my coefficient. I honestly don't know if that's spelled correctly. We're just going with it. I'm sorry. I am who I am. A term without a variable, so like the 7, that is called a constant. Okay, the reason why it's called a constant, or at least what I tell myself, if I plugged in a number for x, that's going to change this term, but that 7 stays constant. 7 is a constant, it's not affected by it. Okay? It is what it is. And lastly, like terms. Like terms are when they contain the same variable. So x, 2x, and 3x are all like terms because they all contain the same thing, they all contain x, okay? Constants can be like terms because they all contain nothing but the number, okay? So here's an example, all labeled in 3. The terms are separated by either addition or subtraction. Like terms have the same variable. 7 is the constant. So let's look at this one. It's slightly different. Let's see if we can label it. This box is pointing to all 3 terms. Very good. This box pointing to the 9, that is my constant. And be careful. The 4 and the 2 are coefficients. I really don't know that. It might be a unit somewhere. Coefficients. If it was 4n and 2n, those would be like terms. Okay, the whole thing, but just the 4 and just the 2, those are the coefficients. All right. Okay, we're just going to keep practicing. Always have those models in your mind, but do we know that we're not always going to draw models for all these same questions? Yes, but you can always vision. Okay, if I have an x and another x in total, I have 2x. If I have a rectangle and another rectangle, together I have 2 rectangles. Right? Yeah? Okay, we haven't looked at multiplication with this, but let's throw it back to elementary. Multiplication usually means groups up. Okay? So, starting with groups up in like the distributive property where we did however many groups of this, start with what's inside. I'll draw the model, you don't have to, but it helps you understand. I'm going to start with 6x. 1, 2, 3, 4, 5, 6. Then it says I need to do 4 groups of 6x. Okay, so I'm going to copy and paste 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so in total right now I have, right now what I see is 24x, but I still have to do that negative. If you remember back at the beginning of school, negative sometimes means like the opposite of. So if I have 24x, the opposite of 24x would be negative 24x. Okay, even though those are unlike because of multiplication, it's talking about groups of. I multiply, and then that sign's the same, so the sign's the same, this is sign. Okay, but signs are different in this one, so that's why it works. Okay, so go ahead and try it out. Simplify these expressions. Combine like with like, adding like with like, but then multiplying with whatever. Try it out, even if it's wrong, it's not wrong. All right, so talking about the grouping, can I do 3 times x? Can I do 3? Yeah, of course. So that would give me 3x times 11 gives me 33x. Again, I can do that because it's talking about the groups of this, groups of that. X plus x plus x gives me 3x. Okay, on C, let's have a volunteer. Okay, volunteer. This is going to be 8x plus 8. Again, I can only add or subtract like terms. So 7x and x, those are like terms. In total, that would be 8, and then the 8 by itself. Can I go further, one step further, and say 16x?
No.
No. Okay, think of the model. That's 8 sticks and 8 rectangles. Order of operations. I know it's sort of like we're sort of rearranging stuff. I still don't know what x is. I still have to multiply 8 times whatever x is, and then I can add on to it. Question? Yeah.
So
First one?
yeah, the first one, you just take away the x and just
Multiply the 3. Yeah. In this case, yes. We can see, as we keep going, we can see if that's a rule or an exception, because it could be one of those before or something like that. But I think that should work every time. Okay? I don't want to say for sure. All right. Of course, we can do word problems because they're our favorite. Oh my gosh. Okay, 3 friends will pay X dollars each for admission tickets to the museum, plus $1 each to view the mummy exhibit. A 4th friend will pay admission, but will not see the mummy. Right? And simplify the expression that represents the total cost. So if I were to do the most detailed thing, how many admission tickets are we getting for this first sequence? 3. So we have X plus X plus X, right? Plus $1 each to view the mummy exhibit. So plus 1 plus 1 plus 1. Then we have a fourth friend. What are we adding for that fourth friend? X. Okay, but raise your hand if you want to write that out every single time. Nah, no one's raising their hand. Okay, what could I do instead? Combine like terms. So my like terms are the x's here and then this guy right here. Total, I have 4x. Okay, then 1 plus 1 plus 1 is 3. Would you much rather do that?
Yes.
Yes. Okay. I know. How does she do it? Yes, sir. That's exactly what I'm about to do. Okay. Kate just brought up, well, couldn't you figure out like, so each person's going to do x plus 1. They're doing their ticket plus $1, right? And how many times are we doing that? 3 times. But then we have that one friend who's just doing the x. Then we can distribute, right? 3 times x gives me 3x. 3 times 1 gives me 4. 3 times 1 gives me 3 times 1 gives me plus this guy. Okay. Could I still combine some of these terms?
Yes.
Okay, the 3x and the x still makes 4x plus 3. No matter what, when you simplify it down, 4x plus 3. Gucci? All right. Now, this isn't going to happen so much this year, but in the future, they will start adding multiple variables. Okay? You won't just have x's, you'll have x's and y's, as I mentioned. You can only combine like with like still. Okay? So in this first one, I see x's and I see y's. So x's, we already know on the rectangle. Let's pretend y is a triangle. Can I add those together? No. Okay? So, like, combined like terms, that would give me plus the y on its own. Yeah. Alright. Still teaching, so let's stay tuned. Okay, talking about the grouping. Can I add 2x plus y? No, but I can. What's that word? Distribute. Thank you. Oh my gosh. Okay, 4 times 2x is going to give me 8x. And then 4 times y, 4y plus 4y. It's an equivalent expression. I'm not solving, just writing it a different way. Yes, ma'am? When I can't add the things inside. Okay, and then it's right outside the parentheses to multiply. All right, go ahead and try those next week. Pause and play. All right, let's look. So, order of operations. Can I add the y plus x inside parentheses?
No.
No. Okay, but again, talking about all those properties that we've talked about before. This is all addition. Okay, do y'all agree with that? 14y plus x plus 22y. Even though there's grouping, we've talked about like with the associative property, that order of addition really doesn't matter. The parentheses really doesn't change it when it's all addition. So could I go outside and add these plus these? Yes, I can. So in total, I would have
36y
plus x. Same thing. Okay? For B, which ones are my like terms? 3x and the 2x. In total, that gives me
5x
and
9y.
what goes in between them? Plus 9y. Okay, can I add what's in the parentheses? No, so I distribute. Very good. Okay, that's going to give me?
21x
Nope.
7y.
Plus 7y. Remember, if Ms. Otto doesn't distribute candy to everyone, I hear about it. You don't distribute to everyone in the math, you hear about it. Okay? So, partner practice is that next little chunk. If you finish all that, you can go ahead and start on the homework. We'll check in a few minutes. I do also want to go ahead and remind the class and all of this. We have a ticket tomorrow. The ticket tomorrow involves the algebraic expressions from the modeling and the plugging in the numbers and solving like a warm-up. We have simplifying like this. There's a little bit of distributive, stuff like that. Stuff we have been practicing this week. Be aware. Okay, very good.